We shall see how to solve the system of linear equation by using Gauss elimination method. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world. Solve the system of equation x plus 2y plus z is equal to 3, 2x plus 3y plus 3z is equal to 10, 3x minus y plus 2z is equal to 13 by using Gauss elimination method. So they have given 3 equations and 3 unknowns. Solution: consider x plus 2y plus z equal to 3, 2x plus 3y plus 3z is equal to 10, 3x minus y plus 2z is equal to 13, and consider this as equation 1. So all 3 equations together is considered as an equation 1. The augmented matrix is given by A colon of B equivalent to A is nothing but the coefficient of a matrix which we get the coefficient of a given equation, and B is the constant matrix which we get the constant value of a given equation. So we can write the matrix augmented matrix as 1 2 1 colon 3 2 3 3 colon 10 3 minus 1 2 colon 13. So before the colon is the coefficient of the equations, and after the colon is nothing but the constants of the given equations. So it is the augmented matrix. According to Gauss elimination procedure, we need to make the first element of the second row and first element of the third row to 0 by using the first element of the first row. The augmented matrix A colon of B equivalent to the first row, whatever is there, it will be unaltered. So it will be 1 2 1 colon 3. Now we need to make the element 2 of the second row, that is the first element, as 0. How we can make this one 0? By using a row elimination method, by using the element 1, that is A1 1. So here it is 1. By using that 1, we need to make the element 2 as 0. So it can be done by writing R2 equal to R2 minus 2 R1. Here you can observe R2 equal to, I am telling, but I am not writing equal to sign, I have written an arrow mark. That means the row R2 has been changed with R2 minus 2 R1. So here the first element is 2 minus 2 into R1. The first element of R1 is 1. So minus 2 into 1 will be minus 2. 2 minus 2 will be 0. The next element is 3, and of the row 1 element is 2. That means 3 minus 2 into 2. Minus 2 into 2 is minus 4. 3 minus 4 is minus 1. The next element is 3, and the next element of R1 is 1. So 3 minus 2 into 1. Minus 2 into 1 is minus 2. 3 minus 2 is 1 colon. The next 10, that is of second row, and for the first row it is a 3. So 10 minus 2 into 3. Minus 2 into 3 is minus 6. 10 minus 6 is 4. Now we need to make the first element of the row third, that is a 3, as 0 by using the first element of the first row, that is by using 1. So it can be done by writing R3 equal to R3 minus 3 R1. So first element 3 minus 3 into first element of R1, that is 1. 3 minus 3 into 1. Minus 3 into 1 is minus 3. 3 minus 3 will be 0. The next second element minus 1, and second element of R1 is 2. So it is minus 1 minus 3 into 2. Minus 3 into 2 is minus 6, and here it is minus 1. Minus 1 minus 6 will be equal to minus 7. The next element is 2, and that of the row 1 is 1. 2 minus 3 into 1. Minus 3 into 1 is minus 3. 2 minus 3 will be minus 1. The next colon. Then the next element is 13 and that of R1 is 3. So 13 minus 3 into 3. 3 into 3 is 9. 13 minus 9 will be equal to 4. So this is the first step. This is the first step of the Gauss elimination method. So here what we made, we have used the first element of row 1 and made the first element of row 2 and first element of row 3 as 0. That is, using A11 we have made A21 and A31 to become 0 by using row elimination method. It is the first step. So it is the augmented matrix after applying the first step. Now we need to make this one by applying a second step. That means we need to write down the augmented matrix by applying the second step. The augmented matrix A colon B equivalent to. So here, while applying the second step, we are using the second element of the second row to make the second element of the third row to 0. That means we will be using A dash 2 2 to make A dash 3 2 to make 0. We will be using A dash 2 2 to make the element A dash 3 2 to become 0 by using row elimination method. That means the first row and the second row will not be altered. So we write those two rows. After that the third row. So we need to make minus 7 as 0. So how to make minus 7 as 0? We can write R3 equal to R3 minus 7 into R2. So when we apply R3 as R3 minus 7 R2, so first one 0, that is the third row first element 0 minus 7 into second row first element is 0. So minus 7 into 0 will be 0, 0 minus will be 0 minus 0 will be 0 minus 0 will be 0. Then next minus 7, that is the second element of R3 and minus 1 is the second element of R2. So minus 7 into minus 1. So minus 7 into minus 1 will be plus 7. Minus 7 plus 7 will be equal to 0. The next third element minus 1 and that of R2 is 1. So R3 minus 7 R2 minus 1 minus 7 into 1. So minus 7 into 1 will be minus 7. Minus 1 minus 7 will be equal to minus 8. Then colon. The next is 4 and that of the second row constant is 4. So 4 minus 7 into 4. Minus 7 into 4 will be minus 28. 4 minus 28 will be minus 24. So it is the augmented matrix which we get after applying the second step. And you can observe you have got an upper triangular matrix. So it is an upper triangular matrix. By using the above matrix we get. So this one we convert into system of linear equations. So we can write 1, 2, 1, colon 3 whatever is there. That first row we can write in the form of an equation as x plus 2y plus z equal to 3. X plus 2y plus z is equal to 3. And the second row is 0, minus 1, 1, 4. So 0 into x will be 0. So we won't write that term. Minus 1 into y will be minus 1. And 1 into z will be z and 4. So we will be writing minus y plus z equal to 4. Minus y plus z equal to 4. Then by considering the third row, x and y terms will be 0, whereas the z term is minus 8. This is a minus 8z equal to minus 24. So this is the equations which we get by considering the augmented matrix which has been reduced to an upper triangular matrix by using Gauss elimination method. Now next step is you need to consider the last equation which we have got. So consider minus 8z equal to minus 24. So this we can write z equal to minus 24 divided by minus 8. Minus 24 divided by minus 8. Minus and minus cancel and we get z equal to 3 because 8 ones are 8 threes are 24. Therefore z will be equal to 3. Now consider the second equation which we got from an augmented matrix after reducing to an upper triangular matrix. Minus y plus z is equal to 4. So we can write this one as minus y is equal to 4 minus z. Z taking to other side. So minus y equal to 4 minus z and z is 3. Therefore we can write minus y equal to 4 minus 3. Then next y will be equal to how much? 4 minus 3 is 1 and we get minus y is equal to 1. So it is nothing but y is equal to minus 1. Y equal to minus 1. Now consider this y value and z value. Substitute this in the equation 1 which we have got from an augmented matrix which has been reduced to upper triangular matrix by using Gauss elimination method. Consider the first equation x plus 2y plus z is equal to 3 which we have got from the augmented matrix which has been reduced to an upper triangular matrix by using Gauss elimination method, and we can write x equal to 3 minus 2y minus z. X equal to 3 minus 2y minus z. So 2y when you take to the other side it will be minus 2y, and z it is a plus z. When we write on the other side it will be a minus z. And just now we have calculated the value of y and z. So write those here by substituting. We get x equal to 3 minus 2 into minus 1 minus 3 because y is minus 1 and z is 3. So 3 minus 2 into minus 1 will be plus 2. So 3 plus 2 will be 5. 5 minus 3 will be equal to 2. Therefore x equal to 2. So we have got the value of x, we have got the value of y, and we have got the value of z. You can substitute these values, the system of equations which has been given one by one, and you will consider the LHS. It means consider the LHS of the equation, substitute the values of x, y, z, and we get the RHS. It is for the purpose of verifying whether you have got an correct answer or not. Consider the LHS of the equations one by one, substitute the values of x, y, z. You will get the values upon simplification, and that will be equal to the RHS. It means the left hand side will be equal to right hand side of the given system of linear equations. Therefore x equal to 2, y equal to minus 1 and z is equal to 3 are the exact solution of the given system of linear equation 1. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world. We can verify the values which we have got for x, y and z. Why we can verify is for the purpose of cross verifying whether the answer what we got is correct or not. For that purpose we can do the verification, and it is not a compulsion to write in the exam. Just we can make sure that whatever the answer we have got is correct. For that purpose we can do the verification. The values which we have got are x equal to 2, y is equal to minus 1 and z is equal to 3. Consider the first equation which has been given in the system of linear equation, means which has been given in the question. Among that, consider the first equation. The first equation is x plus 2y plus z is equal to 3. Consider LHS. LHS is x plus 2y plus z. In this one, substitute the value of x, y and z which we have got. So we can write equal to 2 plus 2 into minus 1 plus 3, because x value is 2, y value is minus 1 and z is 3. 2 plus 2 into minus 1 is minus 2. 2 minus 2 is 0. 0 plus 3. 0 plus 3 is 3. Therefore, we get the answer as 3. That is LHS is equal to RHS. That means whatever the answers we have got is correct when we have verified the first equation. Similarly, we need to verify the second equation, and that second equation is 2x plus 3y plus 3z is equal to 10. Consider LHS 2x plus 3y plus 3z. So now substitute the values of x, y and z, which are 2, minus 1 and 3 respectively. So we can write equal to 2 into 2 plus 3 into minus 1 plus 3 into 3. 2 into 2 is 4 plus 3 into minus 1 is minus 3. 4 minus 3 is 1 plus 3 into 3 is 9. 1 plus 9 is 10. So we get the answer as 10. It is RHS. It means LHS is equal to RHS. That means the values are correct for the equation 2 also. Now we need to verify for the third equation. So consider the third equation, 3x minus y plus 2z is equal to 13. Consider LHS 3x minus y plus 2z. So the values of x is 2, value of y is minus 1 and z is 3. Substitute in this one. So we can write equal to 3 into 2 minus, since y is minus 1, write in the bracket as minus 1 plus 2 into 3. So 3 into 2 is 6, minus into minus will be plus, it will be plus 1. So 6 plus 1 plus 2 into 3 is 6. So 6 plus 1 is 7, 7 plus 6 is 13. Therefore it is equal to 13. That means it is an RHS. Therefore LHS is equal to RHS. That means equation 3 is also giving that whatever the answers we have got is correct. That means whatever the answer we have got by using Gauss elimination method or the correct one for the given system of linear equation. So it is just an verification. This need not to be right in an examination. It is for your purpose to cross verify that the answer what you have got is correct or not. Like the video, subscribe to the channel, share this video link with your friends, gain the knowledge and rule the world.